Caleb has a maximum of $25,000 to invest. His financial advisor discusses investment options with him, and Caleb decides to take on less risky investments. His financial advisor tells him to put part of the money in a CD at the bank earning 2.5% simple interest, and part of the money in a bond fund and earning 5% interest. Caleb's yearly goal is to earn a total of more than $750 in interest from both accounts. We're asked to write a system of linear inequalities that describes this situation. Alright, so what are the two unknowns? We don't know how much is being invested in the two different accounts. So I'm going to say let X represent the amount invested in the CD, and I'm going to let Y represent the amount invested in the bond fund.
And both of these amounts are in terms of dollars.
So now let's write two inequalities based on the statements. Caleb has a maximum of $25,000 to invest. Now we have an amount invested in a CD, we have an amount invested in a bond fund. The maximum amount, though, is $25,000. So then X plus Y must be less than or equal to $25,000. The financial advisor tells him to put part of the money in a CD at the bank earning 2.5% simple interest and some of the money in a bond fund earning 5% interest. And the yearly goal is to earn a total of more than $750. So recall our simple interest was principal times rate times time. So what we want is the interest from the CD plus the interest from the bond to be greater than 750. We want it to be more than 750. Now each of those interests is a principal times a rate times a time. So for the CD, the principal is X, the rate is 0.025, and the time, the yearly goal, that means 1 year, so the time is 1. Similarly, for the bond, the principal is Y, the rate is 0.05, and the time is again 1. Now cleaning those up a little bit, X times 0.025 times 1 we usually write as 0.025x. Similarly, we would write the second term as 0.05y. And so here is a system of equations that we can use to model this problem. I'm sorry, system of inequalities, not equations. We are asked to graphically solve this system of inequalities. X plus Y is less than or equal to 25,000, and 0.025x plus 0.05y is greater than 750. So let's kind of think about this. X and Y are amounts of money invested. They can't be negative, so let's only consider positive values for X. Notice that I'm using only a first quadrant grid. And let's graph these like we've done before. I will graph the first inequality in blue. Alright, so let's use intercepts. We have, if we think equals, we have X plus Y equals 25,000. If I let X equal 0, let's find the X-intercept, so I'll let Y equal 0. So then we'd have X plus 0 is 25,000. So then X is 25,000. So then we have the ordered pair 25,000, 0. Let's find the Y-intercept, letting Y letting x equal 0, I'd have 0 plus y equals 25,000. So then y equals 25,000. And so we have the ordered pair 0, 25,000. So just kind of considering this, I'm going to use a scale of 5,000 on the axes. So this is 5,000, 10,000, 15, 20,000, 25, 30,000. 5,000, 10,000, 15, 20,000, 25, 30,000. Alright, so I have 0, 25, or I have 25,000, 0. I have 0, 25,000. I will draw a solid line through those points. And testing, and if we just sort of think about it, if the maximum is 25,000, we can test whatever point we want. I'll test the origin again. Testing the origin is 0 plus 0 less than or equal to 25,000. Yes. So that means I would shade below that blue line. I'll graph the second inequality in red. Again, thinking equals for the moment. Let's find the x-intercept. So I would have y equal to 0. 0.025x plus 0 is equal to 750. We go through the division here, dividing through by 0.025. And we find that x is, let me bring out my calculator here, 750 divided by 0.025 is 30,000. So our x-intercept is 30,000, 0. Finding the y-intercept, letting x equal 0 would yield 0.05y is equal to 750, dividing through by the 0.05. Y is 15,000. So we'd have the ordered pair 0, 15,000. Plotting those points, see we have 30,000, 0, 0, 15,000, and drawing the dotted line through those points. Let's test a point here again. How about the origin? Testing 0, 0 is 0.025 times 0 plus 0.05 times 0 greater than 750. 0 plus 0 is 0. Is 0 greater than 750? No, that's false. So I would not shade the region containing 0, 0 in terms of that red inequality. I would shade the region above it, above that red line. So then what to shade? Well, we need to be below the blue line and above the red line. And so I will shade this region in the first quadrant, this little triangular region. Now we're asked to check the solution set, interpret a sample point from the solution set in terms of Caleb's investments. All right, so let's go back to our graph. And let's check a point. Let's find a point that we think satisfies our region. So how about we go with the point 5,000, 15,000, right? Let's do this point right here. 5,000, 15,000. That appears to be in clearly in the region. So let's check 5,000, 15,000. All right, the first inequality was x plus y was less than 25,000, less than or equal to 25,000. And this is fairly easy to check. We have 5,000 plus 15,000. Is that less than or equal to 25,000? Yes, obviously. 20,000 is less than or equal to 25,000. That checks out. Alright, so we have that satisfied. Now what about the second inequality, which was 0.025x, 2.5% on the first account. So 0.25x plus 0.05y is greater than 750, right? We're checking the interests now. So 0.025 by 5,000 plus 0.05 by 15,000. Is that greater than 750? Alright, so we go through the arithmetic here. 0.025 by 5,000 is $125. So he would earn $125. If he invested $5,000, he would earn $125 in the CD. And let's see, 0.05 by 15,000, he would earn $750 from the bond. Is that greater than 750? Well, yes. 875 is greater than 750. All right, so one conclusion would be that Caleb can invest $5,000 in the CD and $15,000 in the bond fund to meet both requirements.